So let's walk through how to solve this crashing exercise. We've been given a network diagram, and we have also been given a table that contains our normal time and costs, our crash time and costs, and once again the slope. And if you remember from the first exercise, that slope is the amount per day it will cost to crash these various tasks. We are also given the maximum crash time. Notice once again we have a task that cannot be crashed. So what we want to do is figure out the initial network. So we want to figure out the critical path because we only want to crash those things that are on the critical path. So we will fill in our various values here. I'm going to put a X after the 10 for A to denote that it cannot be crashed. And then I'm going to try to figure out what is the longest path. Well, you can see here that we have a couple of areas of convergence in our network. So the critical path here, since A and B are in parallel, and B is going to be the longer one, is going to be B to C. And then the longer one here of these three things that happen in parallel is going to be F. And then go back to G. If we add these all up, we're going to find out that the duration is 40 days. Our total direct costs, we're going to get that by going back up here and adding up all these values here, because we want to know what it is prior to any crashing. And if we add those up, we'll find it's 14,200. So now we're going to come down here and we need to actually figure out between B, C, F, and G, which is going to be the cheapest to crash. So let's go back here to this table again and let's mark these. I like to do this. I have B as one candidate, C is the other candidate, F is the next candidate, and then finally G. So looking at the costs, I have $300, $1,500, $600, and $100. So I'm going to do B. So I'm going to go here and put 11x because B can only be crashed one time. Our critical path is still going to remain the same. Remember, it can change as we're going along, so we want to think about that. We're now down to 39 days. It was 14,200 rather. Our normal direct costs and additional cost of crashing is just $100 for B. So that's the cost of the project at 39 days. So now we need to look at C, F, and G, because B is now kind of no longer a candidate. So I have 600 for C, 1,500 for F, and 300 for G. So I'm going to choose to crash G, because that's going to be the cheaper option. Would it still work if I crashed F? Well, yes it would, but that wouldn't be the cheaper option. So I'm going to put 7 here, but I'm going to put an X, because once again G is one of these that can only be crashed once. And so I have B, C, F, G. Our project duration is now down to 38 days. If you do the math through here, I think you'll find that's correct. We have our normal costs and our additional costs of crashing. It doesn't matter if you write this down each time. If you want to just carry forward the cost of the last time period and only add the new costs, that's fine as well, just as long as they accumulate. Okay, so that's our cost to get this project down to 38 days. So let's see if we can do it by one more day. Well, now we're going to have to do either C or F. Let's go back up here. We now have kind of taken G out of the running. Okay, so we have to do C or F. So it looks like C is going to be the cheaper. We can do that 2 days, but for $600 per day. Okay, so we're going to reduce C now from 11 down to 10. Still have B, C, F, and G is my critical path. My duration through that path is going to be now 37 days. Our original direct costs were this. We then had in the first crashing $100 for B. We then had $300 for G the next time we did it. And then now we're adding $600 for C. So our total cost of this time period is $15,200. Now we're going to see if we can do it again. We can probably, without having to even go back and look at this, we can probably decide that we're going to do C again because we knew we could do it 2 times. So we're going to go ahead and do that. So in this case, C is now at its maximum crash time. It's going to start to limit our options here a bit. So we have B, C, F, G. Our project duration at this time is 36 days. If you add that path up, we now have our original $14,200, and we have $100 for B. We have $300 for G. We have $600 for C, and another $600 for C. If you add that up, that's $15,800 at this point. So we've incurred another $600. Can we do this one more time? Well, it looks like we still have one thing on the critical path F that we can crash. So we're going to go ahead and do that. We know that that is going to be $1,500. And it looks like we can crash that up to 2 times. So we'll go ahead and do that. So F will go from 9 to 8. Everything else will remain the same. Now what's interesting here is we actually look at our critical path. It's going to be B, C, but then notice that E and F are the same time period. So in some ways we could look at this as being 2 different paths. B, C, F, and G. And we've got B, C, E, and G. Both of those paths are 35 days. Our original cost is $14,200 our additional cost of crashing. We had $100 for B, then we had $300 for G, then we had $600 for C, and then we had another $600 for C, and then this last one we had $1,500 for F. So we're now at $17,300. If possible, calculate the critical path and cost of crashing by one more day. Well, can we do it by one more day? Well, we know we can crash F by one more day. That'd be $1,500. Can we crash E? Yes, E can be crashed for $500. So we can in fact crash this one more day, but we're going to have to crash both E and F if we're going to get this down. Okay, so notice that we're going to have to do both of these, because if we just do one, then we'll still be stuck here at 35 days, and we need to get down to 34 days for the entire project. Okay, so let's go ahead and do that one. And F is now going to be 7x, because it can't go any farther. We had just 2 days possible. E can go to 7 days. Okay. And we once again have these kind of two paths, if you will. And our project duration is 34 days. We have 14,200 from our original cost. We have quite a long list now of, if I write them this way, it'll be a little bit better. These two were from the last time increment together. But if you tally these all up and add them to our normal duration direct costs, you'll find that this is $19,300. Now, it asks us, if possible, calculate the critical path and cost of crashing by 1 day more. Can we crash it 1 day more? No, we can't, because the fact is that if you look at this path here, everything has been crashed to its maximum. So while we could crash E another one, that doesn't help us at all. So we are now stuck. If we were to move this down to 6, you would do the calculation, you'd find we're still at 34. So that doesn't help us at all. We're kind of going to stay there. We can't move any farther. So now we can fill out our little table here. In this case, we don't have incentives, but notice we have indirect costs we're going to have to calculate in here as well. Now I'll see if I can write this in a way that's will fit in here. We know that we're not going to be able to go down to 7 there. So I'll put an NA there. But our initial duration was 40, then we moved to 39, then we moved to 38, then we moved to 37, and then we moved to 36, then we moved to 35, and then 34. Indirect costs, so we're going to add those to get our total costs. It's not like incentives where we subtract it off. We have some indirect costs in this particular example. So when I add these together, I get 17,200. I'm just going to go ahead and put all these in here and then do the addition. Notice the time is going up this way, so that's why we see our indirect costs are actually going up with time. Okay, so we're kind of going back in time as we move from left to right. Okay, so I'm going to add these all up as we go along here. Even though I've had a moderate increase in my direct costs, there's been a substantial decrease in indirect costs. So it is actually a less amount as far as the total amount. Okay, so if we look at what would be the optimum time period here, well, it looks like this is the least amount of cost. So we'd want to crash this by 2 days.